Now let's discuss a topic known as least common multiples. Finding the least common multiples is a process where we understand the list of multiples that it's created when we multiply two values by all the counting numbers and identifying where they have a common thread. So for example, visually speaking, we can see how this is done with the following visualization. The two wheels that you see here have a certain diameter. Let's say this diameter is 10, this one has a diameter of 20. So imagine as I roll these wheels that the arrow, as it goes through time, creates sort of the following illusion. So for 10, it bounces around something like this. Imagine that it's nice and steady. And as it goes along, the arrow touches in certain places, right? And each one of these distances is a multiple of 10 from the starting position. So the very first list here would be 10 units long. The second would be 20. The third being 30, 40, 50, so on and so forth. Now, I can do the same thing, and notice how this works out. When I multiply through here, I end up with a similar distance for my second wheel. As it bounces along, the first distance from the start would be already 20, and then the second distance would be 40, the third being 60, so on and so forth. So what do they have most in common, or at least in common? Well, 20. They both actually start to coincide at the 20 mark. And again, here at 40. So you notice this pattern of repetition as the wheels continue to roll. This is similar to the very first technique we'll talk about as far as how you actually find the least common multiple. So you can do so first by simply, given two numbers, listing the different multiples of each, and then look for what the smallest number that appears on both lists. That's the least common multiple. Now there's another technique that I'll talk about in just a moment. It's called using the prime factors method, where essentially we write each number as a product of its primes, which is the prime factorization. When we list the primes of each number, you're going to actually match the primes vertically and bring those down into a new list that will comprise your LCM, or least common multiple. Multiplying all the factors together gives you the LCM. We'll see how that works in just a moment. So, given another example here, we're asked to find the least common multiples of 15 and 20. So if I repeat this process, I have 15. Now the multiples of 15 would be 15 times 1, 15 times 2, which is 30, 15 times 3, which is 45, 15 times 4, so on and so forth. Repeating again for 20, my multiples list would be 20 times 1, which is 20, 20 times 2, which is 40, 20 times 3, which is 60. So where do they have their first term in common? Well, it is at 60. So we could say that the least common multiple of these two values has got to be 60. So let's look at our alternative method for approaching this. 12 and 18. Now I could list these in terms of their multiples again, but alternatively I could actually identify what the prime factors of each of these are. So 12, we saw earlier, was something like 3 times 4. Well, 4 is actually not a prime number, but it breaks down into 2 times 2. So I could say the prime factors of 12 are 3 times 2 times 2. Now let's list the prime factors of 18. 18, we could say, is 3 times 6, right? Where 3 is the prime number, but 6 actually breaks down into something like 2 times 3 again. So here's how we create our LCM. Identifying the terms that they have in common, I see that they both have 3's, so we'll list that once. They also both have 2's in common, so we'll list that once. And then I can list the remaining values. So there's another 2 and another 3 here. So anytime that the two lists have the same value, we only put it in our LCM list once. So that gives me 3 times 2, which is 6, times 3 times 2 again, which is 6. Therefore, our LCM between these two values should be 36. And sure enough, if we approach this in our alternative method, we can say that the multiples list for 12 is 12, 24, 36. 18, we get there pretty quickly. It's 18 and straight to 36. So sure enough, both of these techniques work. Now, the trick is understanding when to use which. As for most people, you will reach for the tool that you're most comfortable with. This listing method will work. However, without a calculator, it can actually start being difficult to get to some of these higher values. And so I suggest to you that in instances where you're uncomfortable with your skill set there, to use the LCM method where you identify the prime factors that they have in common, list them once, and then list the remaining factors, and that product that they create will then give you the LCM. Okay, that's going to be it for chapter 1.1. We'll see you next time.